Welcome again friends, welcome again in our fourth video of our pedigree lecture series. So in this lecture video we will going to discuss this example. Okay, so without any wasting time, let's discuss. So first of all, as I have told you in my previous video that you need to find out whether it is dominant or recessive. So this is generation 1, this is generation 2, this is generation 3, and you can say this is generation 4, this is generation 5, right? So the trait is not expressing itself in case of generation 1. It is also not expressing itself in case of generation 2. It is not expressing itself in case of generation now sorry it is expressing itself in case of generation 3 but not in other generations, generation 4 5. So we can easily conclude that it is a recessive trait, right? Now we need to talk about whether it is autosomal or X-linked. So as I also previously told you in my previous video, if you have not watched it, then please go to my YouTube channel and watch it. You will be able to know this pedigree very well after watching this. Okay, it will be helpful to you. Now, so whether it is autosomal and X-linked, we need to talk this. So as I have previously told you that the trait, if the trait is equally distributed among male and female, then we can conclude that the trait is autosomal. Okay, so here we can easily find out that one female is affected and one male is affected. So by blindfold we can easily conclude that it is an example of autosomal recessive trait without any further confusion, right? Now they are telling us to tell the genotype for 1 2 3 4 5. So for this we need to know the genotypic analysis. So don't worry, let me write the genotypes we need to know for assign genotypes in case of autosomal recessive trait. Okay, now welcome back. So as they are telling us about autosomal recessive, or we can say we can easily conclude that this is an example of autosomal recessive trait. So here we have carriers. As I have previously told you, whenever you find that that your pedigree is telling about a recessive trait, then the heterozygous genotype will be a carrier. That means heterozygous genotype will not show the phenotype that is expected if the trait is present in it, or gene for that trait is present in particular individuals, right? So as we are telling it, so now the question is why they cannot express the despite having the gene for that particular trait. The reason is very simple. As we have concluded that it is an example of recessive trait, so the problem, or we can say the genotypic change, is simply due to the presence of the small a. The individual becomes diseased due to presence of small a, but it still have capital A. And if you have basic knowledge of Mendelian genetics, then you can easily conclude that capital A have the ability to mask the expression of small a, right? And this is this is also the reason why in case of dominant type, despite having a normal gene, we have our heterozygous genotype containing individual as diseased, because they have the dominant gene that is causing the disease, and small s expression is masked by it, right? And this is the simple reason why in case of autosomal recessive trait, despite having a disease causing gene, the our individual is normal, right? But as it still have a gene, or we can say recessive gene, okay, it still have the ability to spread the disease in its progeny. That is why we assign the term carrier. Okay, it has it carries the gene that have the ability to show the disease, but due to the presence of dominant gene, it does not have the ability to express itself. but that does not mean they're not having the gene. So they have the ability to pass this in their next generation, and that is also the reason why in case of recessive trait we have skip pass generation. Okay, so I hope that you have cleared all the genotypes that you need to know to answer autosomal recessive type, right? So now let's come back here. So welcome back. So as we have concluded that it is an example of autosomal recessive, then we can say all the unfilled symbol have either genotype capse capse or capse mode. If they have capse capse, then we can conclude that they are totally normal. If capse mode, then we can say if they are total carriers, right? So and the field symbol will obviously have genotype small a small a. So we can conclude that the number 3 individuals genotype is small a small a. Okay, and now we have to talk about this. So let's look here. In that case, as both the parents having both unaffected children, we can conclude that the genotype is not capsis or small a. Okay, because if they are having something like capsis small a, then there will be a presence of small a that will cause result of what? Result of a diseased progeny. But there is another question that we need to, or another criteria that we need to consider, that this son or is married with another woman and they have two diseased children. Okay, so if we conclude that as it is not showing itself, if we conclude that whether it is recessive type, no sorry, whether it is heterozygous, have genotype containing female, but there is not probability that if it is a small a. So no, as my English speaking skills is not so well, but I want to explain you all of you these things very well, so I convert my language into Hindi. Okay, so देखिए एक बात, हम लोगों को ये चीज़ पता चल रही है पेडिग्री को देख के कि इस इंडिविजुअल ने हम कह सकते हैं इस मेल ने इस फीमेल के साथ शादी के बाद इसका एक दो तीन चार पाँच बच्चे हुए हैं, उसके उनमें से दो डिजीज्ड है. ओके, सो वी कैन सिंपली कंक्लूड दैट अकेले इस फीमेल के पास अगर कैरियर टाइप का जीन होगा तो उसको अगर हम स्पेनिश स्क्वायर करते हैं कैप्से कैप्से के साथ, तो देयर इज नो प्रोबेबिलिटी दैट देयर विल बी ए डिजीज्ड चिल्ड्रन, राइट? So there is 100% sure that this male is also have the genotype capsa small a, right? And that is the only possible way to have disease male and female children. Okay, so this also wants to tell us that their grandson, or we can say their this individual's father or mother, one obviously have capsa mode. Why? Because if there is no presence of capsa mole, then how this mole comes here, right? So the answer will be both are possible, but the condition it was, if the father is having capsa mole, then the mother will have capsa capsa, and if the mother having capsa mole, then the father will have capsa capsa. This is the criteria, and if the criteria is fulfilled, then there is a chance that this male have genotype capsa mole, and this capsa mole again mated with capsa mole, and that is the reason they have small a small a, right? Now let's come here. So we have concluded that one have either capsa small a. Okay, so if one is capsa small a, another one is capsa a small a, okay, a small a. Okay, so we have assigned them as capsa small a. So individual 2 will have either capsa small a as the Punnett squared, suggesting us, right? Now come here. In case of individual 3, as it is filled, so we can conclude this blindfolded that it is small a, as it is an example of autosomal recessive, and I have told you that small a simply tell us that individual is diseased, right? Now come here. If it is small a and their son is not having the disease, so we can easily conclude that this female has genotype capse, right? So after Punnett squaring, we will all have capse small a, capse small a, capse small a. Why? I hope I have not to tell you, because मैं जानता हूँ कि आप लोगों को अच्छे से Punnett स्क्वायर करना आता ही होगा, फिर भी मैं कर देता हूँ, किया जाता है. So a small a, a small a, a small a, as because 4 possibilities are a small a. So individual 4 will also be a small a, right? Now again देखिए कि इस इंडिविजुअल में भी कोई भी फील्ड सिंबल नहीं है, दैट मीन्स द डिजीज इज स्टिल नॉट एक्सप्रेसिंग इटसेल्फ, राइट? सो we can easily conclude that there will be capse, and if it is capse, so by simply Punnett squaring we can conclude that the chance of the 50 individuals, whether it is normal or whether it is carriers, it is 50%, okay? Because we do not have further data. If we have, then we will again conclude its genotype by considering their progeny, but we do not have further data, so we have to conclude that both a small a is possible, okay? So for 1 and 2 the criteria is if 1 is capse then 2 must be capse small a, if 2 is capse then 1 must be capse small a. 3 and 4 the criteria is fixed, and in case of 5th equal possibility, okay? If a is also possible or a small a is also possible, we do not have further data to judge this, so this is your answer, okay? So this is an example from MIT coursework regarding autosomal recessive, and I hope it is crystal clear to you, and if it is, please like the video, share with your friends and subscribe the channel. Thank you.